Okay, so for this portion, we're going to be talking about this is on page 3 of our first section on inverses. This is on uh, section 3.5, day 2. So how do we find linear inverses? And what I want to make sure that you can look at for something like this, we're basically going to be going through a bunch of examples. And so my thought would be that this section is about sort of if you're not sure how to do something, go back, watch these, see if you can kind of get the idea based upon what we have here. And I don't think it should be too terribly bad. And they're really pretty good examples for what it is that we're going to need to do. So as we start off, first question asking which of the following represents the inverse of a linear function? What we're going to be doing for almost all of these is just going through the steps of finding the inverse and what it means. So with this one, let's go through the process and let's make sure that we can kind of get what we need to do. So our first step is to change the x and the y. So this y is going to become an x. We've got this 2/3, that becomes a y plus 8. Now, please listen. There's a fraction there. I know that you're afraid of that fraction, and that's okay. I respect your fear of that fraction. They're not difficult because all we're doing here is killing that fraction. And that's an easy thing to do. Okay. So here is my advice to you when we're going to be dealing with these. When you have a fraction, we're going to have to address it. Let's get everything away from the fraction first, and then we can address that fraction. So let's first now say, well, we got that 8 there. Let's move that to the other side so we don't have it to worry about anymore. We'll have to do a minus 8. Minus 8. We'll do a rewrite here, and we will have x minus 8 is equal to 2/3 y. Now, look, I respect the fact that when you see a fraction, it freaks you out because you're like, I don't know what to do. I don't know how to take it. It's fine. We could divide both sides by that fraction, but it's a giant pain in the butt, and that's not something we want to do. What I think would be the best thing for us to do, and the way that I try to teach getting rid of fractions, is to get rid of it in 2 steps. Okay? When you think about what a fraction is, you're multiplying by that top number and dividing by that bottom number. Okay? So the first thing that I would do is to kill the fraction by getting rid of the bottom number. Then it's not a fraction anymore. And so in this case, since this is divided by 3, what we have to do to get rid of that fraction is to multiply by that same 3. Those are inverse operations, so they will cancel each other out. Now listen, the reason why I brought the 8 over here first is because what tends to happen is when you're doing that and there's more than one thing there, you tend to forget to include everything with that bottom number here. So I'm going to multiply this by 3 because divided by 3 and times 3, they will cancel each other out. But I have to remember that there are 2 things on this side. So I'm going to put parentheses here, and I'm going to multiply by 3 there. So times 3 on this side and times 3 on this side. I'm going to have to distribute that 3 to both things. It's fine, but it's something I can't forget about doing. A lot of times that's where mistakes happen is you forget that both things are going to get that 3. And we want to kill the fraction. Like right now, that times 3 and that divided by 3 cancel out. So my new equation on this side, I don't have a fraction anymore. It's just 2y. Easy. On this side, however, when I multiply that 3, I've got to remember to bring it to both things. I'm going to have 3x, I'm going to have that minus, and then 3 times the 8 is going to give me a 24. So now I have an equation with 0 fractions, okay? Kill the fraction. Everything from this point should be completely simple, but I'm still solving for that y. I have that 2 that I have to get rid of. This is why I like getting rid of fractions in 2 steps, because it looks easier once we've gotten to this. When I take care of this, I have to divide by 2. But I have to remember that both of these things have to divide by 2. So instead of doing 1 big over 2, I'm going to save time by putting 1 underneath each. Okay? That way on this side, when it cancels out, that's gone. I'm actually going to use this space over here to write it. And so my new equation there, I've got this y. There's no number in front of it, so I've solved for it. 24 divided by 2 is going to be 12. Still got that minus sign there. Now 3 and 2 don't divide each other out. So I'm going to write that as a 3 over 2 and put the x right next to it. That takes care of my 24. That takes care of my 3. And the y is by itself. This is the equation of the inverse of this linear function. So 3 over 2x minus 12. It's not either of these with the plus 8 and the minus 8. It's this 3 over 2x minus 12. Now, the part about this that I think is important for us to think about then is that the place we can look when we're looking for what happens with the slope is kind of important. This equation is 2/3. This equation is 3 over 2. So essentially, all you're doing in this case is taking the reciprocal of the slope when you're trying to find the equation here. So all of those have 3 over 2, but it doesn't need to be a negative for it to work. If this is a positive 2/3, this is going to be a positive 3 over 2. We have flipped our slopes. We're taking just the reciprocal, and that sometimes helps when we're looking for an inverse if you're trying to narrow down your answers. So 3/2 x minus 12 equals y. That is our equation of our inverse of our original equation up there. Now, process isn't too terrible, but it is something kind of for us to think about. Here's the part that's kind of unfortunate here. The next question is a great question. It's essentially the same thing. You have to find the inverse, but it asks, what is the y-intercept? Now, we're not really going to be able to do that without going through that same process again. And that's fine, because remember, the y-intercept is always that number that we have on at the end here. So negative 12 would have been our y-intercept for this equation. It's not as easy to look at the original equation and figure that out, because 8 went to negative 12 because of what our division part is. I'm going to just say, let's go through the process, and that's the way you'll want to do it. If they ask questions about the inverse, find the equation of the inverse, and then look at the equation to see if you can find those other things. So let's look at that one. And we're going to go through the same things. I'm going to use different colors, though, because I think doing this with the colors that we had from before is going to get a little confusing. So I'll rewrite this one, switching the x and the y. So x is equal to 3/5 y minus 9. Just switch those. Now it's time to solve. Same general ideas. So I'm going to be doing a plus 9, a plus 9. I'm going to get x plus 9 is equal to 3/5 y. Just like I did last time, I'm going to be getting rid of this fraction in 2 steps. So I'm going to multiply by that denominator, because I want to cancel out divided by 5 with a times 5. So here will be the multiply by 5 on this side. So times 5 and times divided by 5 cancel. Put parentheses around this one and do this one times 5 as well. So this and this cancel out, and this is going to be distributed, and we will have 5x plus 5 times 9 is 45 is equal to, that 3 is left, 3y. Okay, same general idea. So now what I have to do, same that I had done before, I'm going to divide everything by that number 3 so I can get that y by itself. I'm solving for the y. And in this case, when I do that, my new and final equation, I'll write up here for us to see, we will have 5/3x plus 45 divided by 3 is going to give us 15, and that is going to equal y. So y equals 5/3 x plus 15. Our slope is 5/3, and they're going to try to trick you with this one here, but that's not it. This is our y-intercept right there. So if this is my y-intercept, that means that the equation here, that y equals 15, is going to be that y-intercept for us to be able to look at. And that's what we're going to be having for an equation here for what the equation of the inverse of this. It's y is equal to 5/3 x plus 15. Our y-intercept is y equals 15. Okay. Now these last 2 problems that are on here, a little less work actually. At least I'm hoping they'll be a little bit less work. We just have to think a little bit about what it is that they're saying. So our first equation here for exercise 5 is asking which of the following points lies on the graph of the inverse. So forget about these for a minute, okay? A lot of times what we want to do is look and go, oh, it's got to be, let's just stop for a second and think about what they're giving us here. This is an equation in point-slope form. So we know the slope is 5. They're not asking us about the equation of the line, they just want a point. So I could find that whole equation, and I think that would be fine, but what I think is important to think about is that when we're given an equation in point-slope form, what we have here is a slope, but they also gave us a point that is on the original graph. So here's what I want to do. I'm going to write point, and what I'm going to put here underneath it is the f of x, so our original function. Our point from our f of x that we can get from here, what we have to remember is we have an x value and a y value. And those are the things that we go here. Now remember, it's y minus y1, x minus x1, all that's great. What you really have to think about in terms of what values came from this is what value would I plug in for the x to make this 0? And what value would I plug in for the y to make this 0? And that's how you find your values that come from the point slope form. In this case, the value in the x that I would plug in right there would be a -2. It's the opposite of this. -2 plus 2 is 0. So my x value would be -2. What y value would I plug in here to make this 0? Y minus 8 would mean a +8 minus 8 would be a 0. So the point that is on our original function is -2, 8. Now they're going to try to trick you by putting one like that on here. That is on the original functions. I want to point on the inverse. And what we have to remember is that with the inverse, we flip the x and the y. So if I'm going to take the same point that is on the inverse of that function, I take these two and I change the order. That y becomes an x, that x becomes a y, and I'll even do the little arrows there. That will be a point that we know has to be on our inverse because we switch every point on the original graph. That means this 8, -2, that right there is going to be my final answer for this problem. Now, we 100% could have solved this for y, gone through the process of finding the equation of the new one and tried all of these in to see which one actually worked in the equation. It just takes a little bit more time and you have to use what's given to you. And that's the reason why I wanted us to do that for this problem, okay? The final one that we're having for exercise 6 is more a thought problem, okay? And it asks here about which of the following linear equations would not have an inverse that's also a function. Now, we talked about this at the beginning when we were talking about how almost all linear equations are one-to-one, which means they pass the vertical line test and the horizontal line test. We said that the only one of these that wouldn't work is a horizontal line, because that would pass the vertical line test, but it wouldn't pass the horizontal line test because it would go through there. So what we want to do is to think about how these graphs actually work. In the case of this first one, we have y equals x, then we have y equals 2, 2y equals x, and y equals 5x minus 1. Okay, so here's a hint for thinking about this. Any graph that has an x and a y in it, y equals this, x equals this, has to have some kind of slope because it's some version of y equals mx plus b. That means we're going to be going either up or down somewhere in here. Now I could draw those, and actually you can use a graphing calculator or Desmos to type this in and see what it's going to look like. That part isn't as important to me, but I do want you to notice there's only one equation here that doesn't have both variables, and that's our equation number 3. And I'll give you just a general sketch. If I solve all of these for y and put them in slope-intercept form, y equals x, that's this line. This y equals 5x minus 1 is going to be one that's going to be like this because it's going to start with a y-intercept of -1. It's going to be kind of steep. This one, if I solve for y, it's y equals 1/2 x, which is going to be like this but less steep. All of these would pass the vertical and the horizontal line test because they are going up at an angle, vertical, horizontal. Y equals 2. That's going to be the one that doesn't. And the reason that it doesn't is because we only have a y value. If I'm going to tell you that y is equal to 2, well, if I go up to where y equals 2, that means that the only value I care about is that. My x can be anything. This is the graph of a y is equal to 2. Clearly, it's going to pass the vertical line test. That's a function. But it's not going to be one-to-one because as soon as I start drawing horizontal lines like this, well, look, this is a horizontal line. It's going to cross it in every place. So since this is not one-to-one, the inverse is not a function. Now, that is a pain in the butt, but it's interesting for us to think about in terms of how we can find the way that these work. You're not going to be assessed on something like that. The skill that we really wanted you to be able to work with is, can you make an equation into its inverse equation by using the steps that we had? But I wanted to make sure that you would see this because I think it's a good way for us to think about what does and does not work when we look at something like that. That's the last example that we're going through, and so that should be the last thing that we're going to record. So good luck, and I look forward to answering questions on your homework assignment.